All right, so this video is going to help with section 10.3 on circles. So we're still in the Conics, 10.3, and this time we're focusing on a circle. So these are actually, I guess my opinion is these ones are the easier ones versus the parabolas and the ellipses and different things. So we have a general formula. The general formula says x minus h squared plus y minus k squared equals r squared. And that's our general formula for a circle, where h and k are the center. Now notice again they have a minus, right? So they're the opposite sign. And then r is the radius of the circle. So let's look at some examples with this. What if I've given, like, all right, the center is at -4, 3. This is our center, and the radius is 4. What is the equation, and how would you graph that? So we would say, okay, we got to plug these in here. So we would have x minus the x value, which is -4. So we'll have a double negative in there, plus y minus the 3 squared, oops, I forgot the squared on that one, equals r squared. And that's our formula. So all you have to do is simplify it by turning this into a plus and squaring this number out, and that's our equation. So x plus 4 squared plus y minus 3 squared equals 4 times 4 is 16. And what would the graph of this look like? Well, let's see here. I have a little bit of graph paper, so it'll make it a little bit prettier. Where'd my ruler go? Okay, so let's make our axis here. I have no idea why I picked the right-hand side one, but okay, here's the graph paper. And we know the center of the circle's at -4. 1, 2, 3, 4, 3. 1, 2, 3. There's our center, and our radius is at 4. So I'm going to set my compass to have a radius of 4. It's almost there. This one's kind of a pain because you have to twirl it. It stays good, but I actually don't like it as well as some of the other ones. All right, oops, wrong way. Okay, so there's at 4. And then we just draw our circle. Oops. I find it easiest to actually move your paper when you're trying to draw a circle than it is to move the compass. Ta-da! There's our graph of our circle. There's our center, radius of 4, so you notice it's 4 away anywhere that you go. All right? So that's how you would draw that one. Another thing you could do, which is not real pretty, but we could do this. If we wanted to put this in the graphing calculator, we could, like if it was a y equals only graphing calculator, you could solve for that y. It's pretty ugly, but we could do it. The way that we do that is we'd want to subtract the x squared plus 4 over so that we're solving for y. So this is going to be to solve for y. And I'm showing you this, but I really don't think this is the best method to be able to graph it, but it does work. Okay, so I'd subtract that whole thing over so that I have y minus 3 squared equals 16 minus x plus 4 squared. So this is squared. To get rid of a square, we square root. So we can square root both sides. Y minus 3 squared. And then we'd square root over here. And when we square root, oops, we would have a plus or minus in front because it could be the negative or the positive squared. That's hard to remember when we take that square root that we can have plus or minus of it. And then from here, this will undo the square. So really, we have y minus 3 here, plus or minus this ugly part over here. Then I can just add that 3, add it in front of your plus or minus, and that is what we could plug into our calculator. So I'd have 3 plus or minus the square root of 16 minus x plus 4 squared. So you could plug this 3 plus all of that, and then 3 minus all of that, and you could get that kind of conic graph on a regular graphing calculator. So I'm going to do that. I actually have already done it. So I did 3 plus, and then I did in the next line 3 minus everything that you saw there, 16 minus. Now make sure with the square root that you have a parenthesis around that whole big section that we were square rooting. You don't have to simplify it any further. I just hit graph and there it is. So it's not super pretty. It's kind of got some missing section, looks like there, but it still is a circle, and it shows you whether or not you got it right, basically. You know, it kind of shows you the idea. So kind of ugly, but you can use the y equals calculator, or you can use the Desmos calculator, and it does it conics for us. All right, so let's look at a couple more questions. What if I said something like this? All right, I have the circle x squared plus y squared equals 9. So right now, what is the center of this circle? Right, it's at 0, 0. And what is the radius? It's at 3. So we know right now it's a 0, 0 and the radius is at 3. What if I wanted to move this down? Move it down 1 unit. I didn't say anything about changing the radius. I just want to move it down. What moves it down? Numbers by the y or numbers by the x? Right, y is up and down, x is sideways. So if I want to move it down, it's like a negative, right? So we're going to think of it as, okay, we know that we can have y minus that value. It's going to be a -1 in there. Squared equals 9. So it's going to end up being plus to move us down. So it's kind of the opposite sign. So the final formula would be y plus 1 squared equals 9. This would be 1 unit down, same radius, and the x is still in the same. We didn't move anything there. What if, same idea, I start with x squared plus y squared still. The center is at 0, 0, and the radius is at 9, right? Because the square root of 81 is 9. What if I want to go left 1 and up 3? So I'm doing two things. Left 1, up 3. Remember, left is got to do with your x's, and that's going to be to the negative, right? -1. And then up 3 is a positive. And so let's set those up. We know it's going to be x minus, because that's part of the formula, the -1, plus, squared, y minus the 3 squared equals the 81. So you simplify that to plus, and that's your formula. Okay, so don't make those harder than they are when they ask you for the transformation a little bit. And they can ask you easy questions too. They could say, okay, what if I have this circle? What is the center of this circle from the equation? Okay, the center is opposite, so it's -6, 0. And what is the radius? It's the square root of this number, so it could be a decimal. This one happens to be 11, because 11 times 11 is 121. So you could be asked the center and the radius from your equation. Those ones you should find fairly easy. Or again, you could have this information and go back. This question I found a little bit more challenging. Wanted to make sure I did this one. What if you want to write an equation that goes through this point? So I'm going to write this out. Write equation that goes through the point 4, -3, and has a center at 0, 0. Zero, 0 is our center. So it has to go through that point, and 0, 0 is our center. Well, we have 0, 0 as the center because this other point would have to be from the center, would have to be the radius out to that point. Because we are always going from the center out to that any other point would be on that radius. So just the idea of that circle is the distance between those two is our r. So that's what we want to do, is we want to use that distance formula and find our r. Okay, and the distance formula says, okay, from one point to the next, 4 minus 0 squared plus negative 3 minus 0 squared. So 4 minus 0 is 4. 4 squared is 16. So this would be square root the distance equals 16 plus negative 3 squared is 9. 16 and 9 make 25. The square root of 25 is a pretty number of 5. Okay, so the radius is 5. If I wanted to write the equation, we know the center is at 0, 0, and now we know the radius. So we'd say x squared plus y squared, because the center's at 0, equals 25. Okay, because 5 squared is 25. And that's your formula. So don't make it harder when they give you kind of the wordy long ones. It looks challenging, but it really is the same kind of idea. All right, so hopefully you found the circle section. I found it to be the easiest one you do this chapter, so hopefully you do too.